Hello, everyone. So welcome to today's webcast, Introduction to Machine Learning with Amazon SageMaker. My name is Scott Stieritz, and I work out of Philadelphia for Thorogood. And today I'm joined by my colleague, Nanda Kumar Ninadurai, who's based out of London. Nanda and I are both business intelligence and analytics consultants with Thorogood, and we both have experience within the AWS platform and across a range of additional technologies, throughout BI and analytical initiatives. So you can also feel free to get in touch with us via our contact details that I'm sharing on the screen right now. And then at the end of the presentation, we'll loop back with these same details once again. Before we get going, we'll take a quick look at today's agenda. We're going to start off with an intro to Thorogood and what we do. We'll then talk about offerings that are available through Amazon Web Services, followed by a general intro to the concept of machine learning. Next, we'll focus in on Amazon SageMaker in particular and think about how it can benefit us within machine learning initiatives. Nanda will then take us through a specific business case, including a live demo of SageMaker, highlighting a bit of the functionality available within the tool, and then we'll wrap up for the day. So like I said, we'll kick off with a very quick introduction for those of you who don't know Thorogood. We're an independent professional services consulting firm, and we specialize in business intelligence and analytics solutions. We operate as a single organization, serving our customers globally, and we use leverage teams of consultants across our offices, including Philadelphia, Boston, and Sao Paulo in the Americas region, as well as London, Bangalore, and Singapore. And then all of our consultants throughout all of our offices are recruited and trained in the exact same way to develop a unique mix of skills. We blend business understanding, technical aptitude, and a deep understanding of the analytical tools and techniques that are available to us. Thorogood offers a full range of services, everything from like business intelligence strategies and roadmaps to architectural design or solution design, down to end-to-end solution implementation, as well as some offerings like data or analytics services and support for production applications, in addition to some BI and analytics-focused products. Then we also support our customers in initiatives like user training or user empowerment. As far as who we work with, our clients typically span 4 data-rich verticals: consumer goods and manufacturing, pharmaceutical and health services, banking, and insurance. And our clients are some leading organizations across these sectors, and we at Thorogood take a lot of pride in the long-standing relationships that we have with many of the organizations that we're showing on the screen. In terms of technologies that we work with, we're an independent consulting firm, meaning we don't work with one specific technology in particular. We do, however, work and partner with many of the key players kind of across the BI and analytics space in order to provide our clients with solutions that best suit their needs. We are indeed a member of the Amazon Web Services Partner Network, which means that we do work with AWS to ensure that we're delivering well-designed, high-value solutions for our customers when the business cases do call for the use of AWS offerings. So that was a quick intro to Thorogood. Now we'll take a minute or two to level set on what AWS is and what the platform can offer us. So AWS, or Amazon Web Services, gives a multitude of offerings to support businesses with technical products and technical services, which can be used to solve business problems. So I'm showing on the screen right now a graphic that AWS uses to group together many of its offerings, just as far as a little bit of organization. So I'll quickly try to talk through a few of these, especially some of the groupings that we commonly see applied to BI and analytics solutions, to kind of give a sense for the broad range of ways in which AWS can be useful. The first is analytics. So there's offerings like Athena, Redshift, Glue, Kinesis, QuickSight, EMR, a bunch more. They all kind of address slightly different things, but generally they enable us to move our data, transform our data, dive into it in detail, as well as organize it in a way that can create valuable business insights. We then have compute. So when we think of a kind of rudimentary definition of the cloud, we think about access to computers that we we don't have stored on our company's premises. And one of the core components of this is access to the compute power of those machines. So there's offerings like Lambda and EC2, Elastic Beanstalk, Batch, a few more that offer scalability of that compute, customizability, and efficiency, really depending on like what we're looking to do. There's database offerings. So there's RDS, DynamoDB, Aurora, Redshift, Elasticache. So in the same way that we commonly structure and attribute and organize our data in on-premises databases, AWS allows us to do the exact same thing across tons of different types of data, except within the cloud. So we can be as involved as we want to be, or as hands-off as we want to be in terms of configuration, database administration. And these database offerings also allow for rapid scaling as, say, our user bases or usage of our applications grow. Next, of course, there's the machine learning grouping over on the right-hand side. So there's products like SageMaker, which we'll be focusing on today, but also tech like machine learning frameworks on AMIs or Amazon Machine Images, and predefined artificial intelligence services that help with things like forecasting or text comprehension, text-to-speech, or vice versa, image recognition, a bunch of kind of predefined services. Next, we have migration and transfer. So a big one here is DMS, or Database Migration Service, as well as server migration service, data sync, and a few more, which allows us to kind of streamline the processes by which we move our data or our tables or entire databases or even whole business applications onto AWS, kind of cutting down the barrier to entry of getting involved in the AWS platform. Lastly, I wanted to quickly mention storage. So there's simple storage service, or as people kind of commonly know it, S3. Then there's some iterations on that like S3 Glacier. There's Elastic File System, or EFS. There's backup functionality. So I mentioned earlier thinking about kind of the base functionality that we get from accessing computers in the cloud. We already talked about the compute piece. This is kind of the other half, which is storage. So there's everything from file systems that attach directly to our machines, like our EC2 instances, all the way up through technology for full-scale data lakes. So it's an extremely flexible category, and it's kind of able to be customized to the specific storage need that you have. So now that we have a basic understanding of what the AWS platform can offer us, let's look into why we may be interested in the first place. I'm sure if you asked 100 different people for a definition of machine learning, you'd probably get 100 slightly different answers. But generally, it's the application of algorithms in a way that computers are enacting some sort of task. But they're also doing it in a way that they're learning from experience rather than requiring explicit outside direction for every single step of that task. There are some high-level categories of ML, including whether or not the learning is supervised, and in other words, whether or not there's kind of a true answer that we're trying to match, such as in classification algorithms, versus just trying to detect some underlying patterns that don't have a definitive truth within our data, maybe something like clustering algorithms. There's also kind of this concept of reinforcement learning, in which rewards or punishments based on good or bad decisions are fed back into the algorithm, and then the algorithm kind of tries to maximize future outcomes based on that past experience. But more importantly, why should we care about it? Generally, we're kind of targeting the types of decisions and behaviors for which we previously would need to rely exclusively on humans, on human interaction. But we can do more than just matching this work or just replicating this work and reducing that human input. We can also improve in a number of areas, like consistency. We can make decisions the exact same way every single time, rather than having, maybe people have different thresholds for different decisions when they're manually analyzing data. We can make that a little bit more standard across the organization. There's also auditability. Our decisions are now definitively based in the data, as well as scalability. So we can scale out to thousands or millions of times the productivity of a single person, and and can even approach real-time analysis. So I also figured it might be helpful to talk through the data science project lifecycle as we've seen it kind of in relation to taking on machine learning initiatives, to think about what some of the common challenges are and where SageMaker can help. So there's business understanding, where we get a clear definition of business challenges or opportunities, as well as an understanding the inputs and considerations that may affect our target business process. We then kind of move into data understanding, where we are gathering what we have available within or maybe even outside of our organization in terms of data, what we want to bring into our analysis. Then kind of a subset of data understanding would be exploratory analysis, where we're better understanding the specifics of each data set, including what variables we have, data quality, like what correlations exist between the variables within those data sets, or other kind of high level analyses. And then we take this and sort of feed it back into our business and data understanding as we get a clearer picture on how well we may be able to address these business questions based on what we have available. We'll then move on to data engineering, meaning like data movement and transformations, maybe creating different features within our data to support the types of analyses we want to perform, and then the actual algorithm selection, training, and tuning, which kind of quickly feeds into evaluation of each of the types of models that we investigate to understand which are performing well. And again, this is iterative. We may better understand as we start to see algorithm performance, the type and format of data that is best going to support these analyses. So we need to change up our data engineering steps a little bit to match that. But eventually, hopefully, we'll come to a model that's of use to the business. So we want to make sure that we're exposing this model to them for interaction, or incorporating the outputs into our production processes. And then lastly, kind of continually monitoring our models once they're up and running, see how they're performing over time, watch for drift as we get new data, identify some triggers for deciding that we need to go back and retrain these models based on new patterns within our updated production data. So we have an understanding of the ML process now, and we want to call out, like I said, a couple common challenges that we see within the process. One is data quality and labeling. So we've seen customers identify high value business questions, then struggle based on feedback from the evaluation phase. Maybe training data sets aren't quite robust enough or labeled in a certain way, but getting that labeled data is very resource intensive and can put a lot of strain on the data scientists or the analysts who are trying to do the analysis. We've also seen struggles with compute power, especially when people are doing local analyses. As you start to bring in more and more data to improve our model's performance, we start tying up our resources locally. We can have our machines running for hours or overnight or over weekends trying to perform heavy calculations. And then sometimes we'll use VMs and kind of do the same run locally pattern on those VMs. We've also seen challenges with versioning and collaboration. So we have multiple people on a team that are all developing locally. They have software and libraries and packages installed on their laptops, and may not be the same. Then all of a sudden, somebody else picks up where they left off, and the process no longer runs because it no longer has the correct dependencies. Or maybe you're not quite sure where somebody left off, what the most up-to-date version is, etc. Experiment tracking is also a common challenge, so it can be kind of tricky to keep track of and compare across many or hundreds of different runs of different iterations of models without a more robust process. Next, a big one is deployment and sharing, especially when we're kind of starting in the realm of local development. We can take a subset of data and then run it through that local process, and then maybe share that flat file results back with the business. But what happens when the business wants it on a full production scale data set? And what about when we want to go from ad hoc analyses, when the data scientist has the time available, maybe once per week or once per month, now to once per day, then to once per hour, and now in real time every single time a new data point comes in. Lastly, there's of course some challenges with managing deployed models. So the same robust monitoring and retraining process that I talked about a couple minutes ago. It's kind of easy to discuss in theory, but more difficult to implement, without a good strategy for it. So if we don't have a plan for monitoring drift or performance and retraining, our models can quickly go from useful to completely outdated. So we have an understanding of common challenges that we may run into during machine learning initiatives, but what is SageMaker? What is Amazon SageMaker, and how can it help us? Well, it's a fully managed machine learning service in AWS that allows analysts and data scientists to work efficiently throughout the full ML process. It doesn't do just one thing. Nearly every individual step of the ML process has corresponding functionality within SageMaker to kind of help streamline. So to help track against the challenges that we reviewed, I included them at the bottom of the screen here. We talked about that challenge of getting sufficiently informative and well-labeled data to be even able to perform the types of analyses that we want to do at all. So ground truth, which is an offering within SageMaker, helps with this. It helps us build highly accurate training data sets for ML and organize workflows for labelers who can accurately label your data, and these can be internal or external resources to your organization. There's also a big piece of this, which is the build piece. So we talked about compute power as well as time spent evaluating models within the modeling phase. SageMaker notebooks give the same kind of notebook UI functionality that nearly every developer is familiar with, but it also allows them to run on elastic compute based on notebook demand, or even grab optimized models directly from the marketplace to reduce time to value. There's also a challenge with collaboration that allows for, like notebooks allow for interactivity across every member of the team within the same code. And then as far as kind of training and tuning our models, experiment tracking is a challenge, investments needed to train our models and evaluate and tune them, maybe evaluate some more. We can handle these in a robust way and even in parallel using experiments. And we can take some of that heavy lifting off of our data scientists by automating some of these pieces, automating model selection, model training, model tuning through SageMaker Autopilot and automatic model tuning offerings. Lastly, we have built-in capacity for the productionization and kind of exposing models to the business and monitoring them. So detecting drift, determining when we need to retrain through Model Monitor and through Neo. So it can be a little bit intimidating to take a business critical process and say, let's take humans entirely out of the loop. What if something goes wrong? What if we want a little bit of closer control or closer review before making hugely important decisions based entirely on ML algorithm results? Well, augmented AI can also help with this. It can keep humans in the loop with review or auditing and override capability of maybe every decision, or maybe only the decisions on which the algorithm's kind of on the fence about going one way or another. So it's really focused on instilling confidence in these decisions. And then kind of the last offering to call out is a pretty interesting one, which is Amazon SageMaker Studio, which is really the IDE through which you can interact with all of this SageMaker functionality in your browser. And it ties, build, train, tune, deployment, and management steps all together. The particularly good thing about SageMaker Studio is that it can manage SageMaker instances and manage their uptime based on the analyses that you're running, helping to reduce costs of experimentation. So that was a quick look at a high-level intro to SageMaker. Now I'm going to hand it over to Nanda to show us SageMaker in action based on an interesting business use case.
Before we quickly move on to the AWS console for a demo of SageMaker, let's quickly look into the business use case and the problem we are trying to solve. So the use case we have here is about a consumer goods company which has a large portfolio of products ranging from everyday products. So for the sake of simplicity, let's say the products are classified based on different categories. And also let's assume the company has managed to get competitive intelligence data from third-party data providers. Now, the business objective is to identify anomalies in the sales volume within the data set so that appropriate actions can be taken if there are any. So before we move on, so what is an anomaly and what is not an anomaly. So let's look into it quickly. So let's say for a given time period, like past 3 years or so, if there is a sudden growth in say during the summer, people are more likely to buy the deodorants, and this has caused some sudden increase in growth of the extra large pack. And so what this means is this is not likely to be an outlier as it is just a seasonal growth. On the contrary, if there is a sudden growth in competitors' brand during a non-summer season, and this was caused due to the standard price decrease, then that is something that we must keep an eye on and see what actions could be done to compete with others. So to achieve this sort of identifying anomalies within the data set, we need to build an anomaly detection model. And in this example, we are using a built-in AWS model, random cut forest, which we'll cover in a minute. We have also created a test data for training the model and have included some custom logic, which we'll cover as we walk through the code. Now let's look into the high-level steps involved in achieving the stated business objective. First, the source files are loaded into an S3 bucket and is used to read input into the Amazon SageMaker notebook. And within the Amazon SageMaker, we are basically looking to build, train, and evaluate the model outputs. And then the output data set is written to another S3 bucket, which can be loaded into a relational database like MySQL, PostgreSQL, or SQL Server using an AWS Lambda, one of the compute resources that Scott mentioned about. And then we can also connect to the visualization tools like Amazon QuickSight or other reporting tools like Power BI, Tableau, or Looker. So as I mentioned earlier, for a use case, we are going to leverage one of the built-in algorithms of AWS, which is random cut forest. So what is RCF? RCF is an unsupervised algorithm for detecting any anomalous data points within a data set. And so obviously best suits our use case at this point in time. And anomalies are observations which diverge from otherwise well-structured or patterned data. Anomalies can manifest as an unexpected spike in time series data, or it breaks in a periodicity, or any unclassifiable data points are called as anomalies. They are easy to describe in that when we actually view it in a plot, they are often easily distinguishable from the regular data. So the orange point here is an anomaly depending on the group that you are looking into. The main idea behind the RCF algorithm is to create a forest of trees where each tree is obtained using a partition of sample of the training data. The random cut forest assigns an anomaly score by computing the average score from each constituent tree and then scaling that result with respect to the sample size. Now let's jump into the AWS console to look into the SageMaker and some workings of this algorithm. I believe many of you might be familiar with the AWS console in general. So let me quickly go into the Amazon SageMaker. Yeah, so on the left side, what you can see is like the different components of SageMaker that Scott was mentioning about related to ground truth, the place where you can have notebooks defined, any jobs that are being processed, any training of the jobs that that are currently there, any endpoints that has been configured as part of your inference algorithm, as part of your inference can also be configured from here. In the interest of actually showing what actually is done to achieve the business objective that we have done, let's quickly look into the Amazon SageMaker Studio. So I've already created a SageMaker Studio here. So let me quickly open it. So once we have the Amazon SageMaker open here, it basically comes up with a welcome page where you can define models. You can also use AutoML functionalities of SageMaker. Yeah, you can also use AutoML features of SageMaker to basically build and train your models. You can also deploy and monitor your models that are being productionized, and then you can also monitor your models and say if there are any drift in data. Then you sort of need to understand what needs to be done so that the model does not become outdated. So now let's quickly look into the code that we have written to actually resolve the business objective that was stated. So we are looking to identify anomalies based on the dataset that we already have. So as part of the first step, we are importing some of the libraries that are required within Python. You're loading the initial data set, you're loading the feature data set, just preparing the data set with respect to setting some indexes, sorting values based on the month date, dropping off some columns just to make sure that the data sets are being cleaned. And then here I'm defining some features dictionary, which I'll use as part of the generate insights method. I'll walk you in a minute. And then here, what we are essentially trying to do is preparing the training data, and we are basically splitting based on the month to prepare the data for training. And we also are preparing the test data set so that we can be sure, like, okay, this is the data set that we are using for testing. And then the next step is where we are basically building the random cut forest model. So if you look into this code, you'll notice that it's a very easy and simple to write one line of code to say, like, okay, I'm creating a session for SageMaker, and I'm creating a random cut forest object using the class. And if you notice here, I'm also specifying the data location, output path, and the two hyperparameters that are very specific to random cut forest algorithm is the number of samples per tree and the number of trees. And this can be optimized and can be configured depending on the use case that we are trying to resolve. And then in the next step, I'm basically creating an endpoint for the algorithm that has been created. So now, as we move through, so I'm just getting the results, and I'm trying to plot in a plot diagram to see, like, what does the data set really look like. And if you see here, this basically has the volume of sales, and I've also assigned the anomaly scores based on the RCF algorithm. But this does not give me any sort of insights in terms of what are the anomalies here, right? So we need to understand what is the threshold for me to define from when do I start calling it as an anomaly. So we do a threshold calculation based on the mean with a gap of 3 times the standard deviation. So based on this threshold calculation, we would have an outliers graph to say, like, okay, the black points that we see here are basically the anomalies that has been created. But just identifying what those anomaly data points are not going to give any business benefit at this point in time. So we obviously need to generate some insights for these anomalies. And so what we have here in the next step is basically looking through the data set, looking through whether comparing the volume that has grown, whether it is a growth or some decline has happened. Depending on that, we are trying to reason out why a particular data point is deemed as an anomaly. And that is something that we will quickly share in a report. So if I quickly jump into a Power BI report, what we have here is basically a cluster chart with the anomaly data points. But the important point to note here is, like, for each data point, we have some inside description added to it. So it has an anomaly score, what is the volume of sales that was attributed to it, and then an inside description which says, like, okay, this is most likely to be caused by decreasing the standard price by 2.59 against the average $23, right? So the driver seems to be the standard price here. But if you look at this point, it says, there are no drivers directed to explain behavior. So it means that the data set and the features that we have configured are not sufficient to basically determine what those drivers are. But as you look into other points, you can also notice that you'll have some inside descriptions being said. Say, like, okay, this is most likely caused by increasing distribution by 0.1 against a particular average number. And this is because the distribution has increased overall. So this gives you a picture of, like, how we can leverage SageMaker as part of your business requirements. With that, we come to the end of today's session. I hope you found this useful. Once again, thank you all for taking the time to join us. If you have any questions or are interested to learn more, please don't hesitate to reach out. I'll bring up our contact details again in just a moment. We also have a range of pre-recorded content available on demand on our website at thorogood.com/perspectives. Once again, thank you everyone for joining today.